Okay, so 7.4 is we're just going to be working on properties of logs and how to manipulate them and do things with them, like order of operations kind of stuff. So first, let's start with the main three properties. So the first one is the product property. So log base b of m times n. So whenever you have a log base b of something being multiplied, you could also write it as log base b of m plus log base b of n. Okay, so the next one is the quotient property, log base b of m over n. What do you think we're going to do with them? Well, we're going to split them apart, but this time, since it's division, we are going to use subtraction. Okay. So the power property, the last of the three major properties, is so whenever you have an exponent, you can bring it out front. So, and we're going to use this later on, but this could be like n times the log base b of m. Okay, these are definitely three things that you need to have memorized, and because we're going to be using them a ton. So the first section of questions, they want you to write it as a single log, so it's already spread out, and they want you to put it together. So log base 4 of 32 minus log base 4 of 2. So what do you do whenever you subtract? Well, we're dividing. So this is going to be log base 4 of 32 over 2. And yes, you need to simplify that 32 over 2 so that your answer is log base 4 of 16. Okay, the next one, log base 3 of 5x plus log base 3 of 2x. What do you do when you add two logs? Well, you're going to be multiplying. So log base 3, I'm going to put it in parentheses, of 5x times 2x. Let's go ahead and clean it up. That would be log base 3 of 10x. Okay, last one of these two. So 2 log base 3 plus log base 9. So what would you do first? Well, it's actually a trick question. You can't combine these because they have different bases. Okay, so whenever you're doing this, it only works if the bases are the same. Okay, so that's just a trick. But let's say, maybe off to the side, let's do this problem if they were the same bases. Let's just say 2 log of 3 plus log of 9. So I just changed them to base 10. Okay, first thing I would do is I would move this to my exponent. So this would give me log base 3 to the second power plus log base 9. Okay, now since we're adding the two logs, we can multiply those numbers. So this is going to be like log of 3 to the second power times 9. Simplify that up, and you get log of 81. Okay, so that's how you would do it if they were the same base. Okay, now, this one, now they have it put together, they want you to manipulate it and expand it out. So let's go ahead and do that. So this one, this is going to be log of 4 plus log of x, because 4x is like 4 times x, right? All right, and then you would put minus log of 7. So order of operation rules isn't quite, it's different in logs. So you could have technically switched this around. Maybe you did log of x minus log of 7 plus log of 4. Anytime you have minus a log, just think it's going to be in the denominator every single time. So even if like they're just in a different order, like I could have switched these around, as long as I had a negative sign in front of that log of 7, it would have worked just the same. It would have been okay. So that's kind of cool. All right, now here's another one, log base 3 of 9x to the 4th. So I could split this up into log base 3 of 9, but wait a second, is that 4 exponent, what is that with? Or sorry, that is only with the x, right? The 9 is not to the 4th power, only the x. So I'm going to keep the 9 separate because it's 9 times, so 9 plus. And then I'm going to go ahead and kill 2 birds with 1 stone and bring that 4 out front because that's the power property. So 4 log of x. Okay. Let's go to letter D and then I'll go back to letter C. So log base 3 of 2x over y to the third. First thing I'm going to do is get rid of this gross negative exponent. How do I do that? Well, you just flip it up to the top, right? The reciprocal. So now I have log base 3 of 2x y to the third. Easy, right? It's kind of long, but you can still do it. So now this will be log base 3 of 2 plus log base 3 of x plus 3, don't forget about your exponent, 3 log base 3 of y. Yes, I know it's long. Okay, now this one should be in that first section, but that's okay. So here's a hard one. We are going to now write this as a single log. I think this actually is one of your homework problems, just to give you a heads up. Yes, they gave you all these weird variables. I know there's not a whole lot of numbers, and there's only one number actually. Don't freak out. Just treat them, do the exact same thing. So I'm going to kind of take this one step by step. So x log of m, let's just rewrite it with our exponent. So this will be log of m to the x. Okay, you doing okay? All right, plus, now I'm just going to move this 1 over y. Since it's in front, it's going to be an exponent. I know it looks weird. Plus log base n, log of n to the 1/2 power. Yes, it's weird. This whole unit's weird. Then drop down that minus log of p because there's nothing to do with it. There's not a power, I meant. So now, what do you think whenever you have a minus? Well, you think denominator. What do you think whenever you have pluses or positives? Numerator. So this is going to be log of m to the x times n to the 1/2 over p. Hey, I know that one was kind of crazy, but it's kind of cool. Okay, this next one is the change of base. I don't know what that random graph is doing there. That's weird. Huh. Okay, so anyway, the change of base formula, I'm going to color code it. So it's going to be like the log base b of m. You can switch this up to the log of m divided by the log of b. And there is one other way if you want to look back in the book where they do it, but I like this better. Okay, so I think this is easier. And this kind of cut off. It was going to show you why it worked, but sorry, it got cut off. So you're just going to have to trust me. I will prove it to you in a second. So when do you use this is whenever your logs are not going to be, like whenever you're solving for them and they are not like a nice, pretty number. Okay, so So use the change of base formula to evaluate each expression. So this one, let's just pretend we don't have the change of base. You don't need to write this down, just watch. So if you were going to solve or evaluate this, you would set it equal to x, then convert it to exponential form. So 12 to the x equals 20. Now you're thinking, can I change 12 and 20 to some kind of number to an exponent that has the same base? Well, no, you can't change 12 or 20, either one of them, right? So that's not going to work. So now this is where your change of base formula comes in. So your change of base, we're going to do the log of 20 divided by the log of 12. It's always the bigger number divided by the base. Okay, so you stick this in your calculator, use Desmos, it's the best. If you have questions, ask me in class. I can help you if you're having trouble typing it in. So anyway, or if you have a different type of calculator that you want to try, Google it is my best advice. Okay, so you're going to round these to 3 decimal places. These are irrational numbers, which makes sense, which is why it didn't come out as a nice, neat number. And that's why we had to use the change of base formula. So this one is 1.206. Okay, easy, right? You could technically do it on all of them. It's kind of lazy on some of them. You don't need to, but if you want to, there's another random graph. I don't know what that's all about. Okay, so log base 7 of 30. So we're going to do, you can't solve this one, so let's just use the change of base. So log of 30 over log of 7. And you get approximately 1.748. Okay, there's two more. I think you should get it. If not, try it. I'll just tell you what the answers are. This one's approximately 3.631. And this one's approximately 2.564. Okay, so now use properties of logarithms to evaluate. So what does evaluate mean? Solve. Okay, so the first thing I'm going to do is write this as a single logarithm. Okay, so whenever you subtract, that means we're dividing those numbers. So I'm going to have log base 2 of 96 over 3. Okay, clean it up. I've got log base 2 of 32. Okay, now we're going to solve this. Set it equal to x. On this one, it comes out nice and easy. I'm actually going to do it both ways. So the first way I'm going to do it the old-fashioned by hand way, and the second one I'm going to use the change of base and use your calculator, and use my calculator, and you're actually going to get the same answer. So if I were going to do this the old-fashioned way, I would do 2 to the x equals 32, and I can rewrite 32 as 2 to the 5th power. Okay, and now my bases are the same, so I can just set the exponents equal to each other. So x is 5. If you were going to use change of base, which you totally could, try it out in your calculator. You would do the log of 32 divided by the log of 2, and it's really cool. You type it in your calculator, and it tells you it's 5. Neat, right? Okay, this next one. Log base 4 of 48 minus 1/2 log base 4 of 9. So first I'm going to rewrite this as 1 log. So log, remember this part's going to be in the denominator because it's minus. And I'm going to move this to the exponent. So I'm going to have the log of 48 over 9 to the 1/2 power. What is it whenever you do something to the I forgot my base 4. What is it whenever you do something to the 1/2 power? Well, you're square rooting it. So now we have log base 4 of 48 over the square root of 9 would be 3. I'm going to keep cleaning it up. So log of 4 equals, what would that be, 16? Okay, now this looks like something I could solve. You could type it in your calculator, but I think it's faster to do this one by yourself. So 4 to the x equals 16. Well, that'd be 4 to the 2nd power, right? So x is 2. All right, last thing for this, we're going to be using natural logs. So these same properties, the product, quotient, and power property, all work for natural logs. So you treat it just like you would. It's going to be okay. Let's do it. So even though the directions say write each expression as a single natural log, even though this is a single natural log, let's just write it in exponent form. So this would be like the natural log. What do you do with the number out front? Well, you move it to the exponent. So the natural log of 5 squared, or you could just say the natural log of 25. Easy, right? Okay, so on the next one, letter B, natural log of 4 plus natural log of 8. What do you do when you add? Well, you're going to be multiplying those numbers. So that's like the natural log of 4 times 8, which would just give you natural log of 32. Last two, almost done. Natural log of 64 minus the natural log of 8. What do you do when you subtract? Divide those numbers. So 64 divided by 8, which will just give you the natural log of 8. Last one. Ooh, this one's a crazy one. It'll be all right. So there's a few different ways to write this. First of all, think denominator for this. Okay, numerator for those because they're both positive. And this time we're going to be distributing that exponent to both the x and the y. And again, there's a couple different ways to write this. I'll show you 2 of them. So I could do the natural log of x to the 1/2, because remember you're moving it to the exponent, y to the 1/2 over z to the 3rd power. Don't forget about that exponent. Another way you could write it is the natural log of x, y in parentheses, has to have parentheses, to the 1/2 over z to the 3rd. So like I would be, either one of those, if you put those on a quiz or a test, I would count it right, because it is right. Okay, so that is it for 7.4. Hope you have a great rest of your day, and thanks for watching.